All right, so we're still sticking to logs. Next, we're going to go into log equations. Okay, so when we have equations, we have an equal sign in there. So that's the difference between an expression and an equation, is that you have an equal sign in there. And then we're solving logs. So when we're solving for the missing variable. Okay, so if I look on my first example, I have -10 plus log base 3 of n plus 3 equals -10. So what we're solving for here is a missing variable, which is n. Okay, so we need to figure out how we can get the n by itself. So starting off, just like we solve any equation, we need to get rid of everything around the n first. Okay, so we do have the log base 3 of n plus 3, but then even outside that, we have this -10 hanging out here. So we need to get rid of that first, and we're going to do so by adding 10 to both sides. And so we have log base 3 of n plus 3 equals, and then -10 plus 10 is going to give us 0. Okay, now once you get the log by itself, then we change it to exponential form. So if you don't remember how to change into exponential form, you start off with the base. So our base here is 3, and then it's to the 0 power equals this piece right here, which is n plus 3. Well, 3 to the 0 power gives you 1, so 1 equals n plus 3. And then to solve for n, we're going to go ahead and subtract the 3. And 1 minus 3 gives us -2. So that's what is equal to n. N equals -2. And that's it. Okay, so let's go ahead and look at the next example here. So we have -2 log base 5 of 7x. So we are solving for x. Okay, so first we need to get the logarithm by itself. So we see, okay, what's hanging out here with the log? Well, we have this -2 up here in the front of the log. So we're going to go ahead and cancel it out. So we're going to divide both sides by -2. These -2 cancel out, and we're left with log base 5 of 7x equals 2 divided by -2 is going to give us -1. Okay, then we're ready to change to exponential form. So it's going to be 5 to the power of -1 equals 7x. So 5 to the power of -1 equals 7x. And then 5 to the power of -1. Remember, the negative exponents doesn't mean a negative number. It just means that it's in the wrong location. So when we write this as a fraction, this is going to be 1 over 5. And this is equal to 7x. And then we're going to go ahead and divide both sides by 7. So 1 over 5 divided by 7 is going to give me 1 over 35. Does this tell us to leave it as a decimal? I can't remember. Let's see the directions. When solving, no, it doesn't give us anything, huh? So we can go ahead and leave it like that, or as a decimal. Okay, the next one here. So we have a log. We don't have a base on this log, but remember, it's understood that it is 10. Our missing variable that we're trying to figure out is m. So we need to see, okay, what's there with the log that we can get rid of? So this +2, we're going to go ahead and get rid of that +2 by subtracting on both sides. And we have log of -m equals 4 minus 2 is 2. Okay. Then now that we have the log by itself, we can rewrite it in exponential form. Remember, if there's no base, there it is, 10. So it's going to be 10 squared equals -m. So 10 squared equals -m. 10 squared we know is 100. That's equal to -m. And then to solve for m, or to get rid of that -1 in front of the m, is to divide by -1. So 100 divided by -1 is going to give us -100 equals m. Alrighty. So next, what happens if there's logs on both sides? So this one, if there's logs on both sides, then in order for this equation to be equal, then this part has to be equal, since it's the exact same thing on both sides. So then from here, all we got to do is set up 5x equals 2x plus 9. And in order for these logarithms to be equal, we're going to go ahead and solve for x. So we're going to subtract 2x. And we get 3x equals, this canceled, so we're just left with 9. Then to solve for x, we're going to divide both sides by 3. And this cancels, and we get x equals 3. Okay, let's go ahead and go to the next one. So here we have log of -2a plus 9 equals log of 7 minus 4a. So since we have logs on both sides, then all we got to worry about is what's inside the parentheses. This part has to be equal. So -2a plus 9 should equal 7 minus 4a. Okay, we're going to start solving for a. So I'm going to go ahead and move over this 4a by adding it. So what I do to one side, I got to do to the other side. This cancels. This gives us 2a plus 9 equals 7. We go ahead and subtract the 9, and we get 2a equals negative 2. We divide by 2 to solve for a, and we get a equals negative 1. And that's it. Okay. The same thing here, we have log base 12 on both sides, exactly the same. So in order for these two equations to be equal, then this inside part needs to be equal, okay? So we get x squared plus 35 should equal negative 12x minus 1. Okay, so since we do have an x squared here, and we have a negative 12x, this is considered a quadratic function. So to find the solutions, we're going to go ahead and have to move everything to the same side of the equation. So this negative 12x, I'm going to move it to the other side and add the 12x. And then we get x squared. Okay, we can't add it to the 12x because they're not like terms. So plus 12x plus 35 equals, that canceled, so it equals negative 1. Okay, then I'm going to go ahead and move this negative 1 to the other side. And we get x squared plus 12x plus 36 equals 0. Okay, now to solve for x, we can do one of two things. Well, there's more things. We could graph it. We can use a quadratic formula that x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You can use that if you wanted to solve the quadratic equation. I'm going to factor. I think factoring is the easiest for me here. So if I factor x times x gives me x squared, and then we're looking for two numbers and multiply to give us 36, but we'll add up to 12. So 6 times 6 gives me 36, and they would also add up to 12. And then you set each one equal to 0. So x plus 6 equals 0, and x plus 6 equals 0. So technically on this one, it's going to give us the exact same answer. So minus 6 means x equals negative 6. And that's how you solve your equation when it's when it's a quadratic formula. And that's it. Okay. Now applying the log of logarithms to simplify. So when we're solving for x and they give it to us where we have two logs on the same side, so we have log of x plus log of 8. So remember, we got to remember our rules from yesterday or the previous lesson of laws of logs. So when we have a plus sign here, we're going to go ahead and condense it, and the plus sign means multiplication. So it can be log of x times 8, okay? And that is equal to 2. And now that we got the log by itself, or we have one log by itself, we're going to go ahead and write it in exponential form. So remember, if there's no base on the log, it's 10. So it'll be 10 to the second power equals 8x. So 10 squared equals 8x. 10 squared is 100. This is equal to 8x. And then we go ahead and divide by 8. This cancels, so we get x equals 100 divided by 8. Let me punch that in my calculator real quick, 12.5. All right, this next one. So again, we have two logs on this side, so I need to condense it into one. So log base 8. Now, because the logs are adding with each other, we're going to go ahead and multiply. So it'll be 2 times 4x squared. This is equal to 1. I'm going to go ahead and rewrite this in exponential form. So it's 8 to the first power equals that. So 8 to the first power is equal to, and real quick before I write that, I'm going to multiply the 2 and the 4. So it equals 8x squared. 8 to the first power is just 8. So to get rid of this 8 with the x squared, I'm going to divide by 8. So 8 to the first power divided by 8 is just 1 equals x squared. And so this one, we don't need the quadratic formula because we don't have, we just have x squared. We don't have x squared plus x or x squared plus 9x or any of that. So I'm just going to go ahead and take the square root to solve for x. The square root of 1 is going to give me plus or minus 1. And that's what x is equal to. And that's it. Our next one, here we have log base 6 of x plus 1 minus log base 6 of x equals log base 6 of 29. So on this side, I'm going to have to condense it into one log. Okay, so we have log base 6 of x plus 1 is going to go on the top, and the denominator is going to go this x here. Okay, and the reason that we have division is because of this minus sign here. Equals log base 6 of 29. So now that we condensed it, we see here that we have log base 6 on both sides. So in order for these to be equal, then this part has to be equal. Okay, so I'm going to go ahead and write it. X plus 1 over x equals 29. Okay, I'm going to go ahead and put this 29 over 1 and cross multiply. So 1 times x plus 1 is just x plus 1 equals 29 times x is 29x. And then I'm going to go ahead and move this x to the other side by subtracting, and we get 1 equals 29 minus 1x is going to give us 28x's. And then to solve for x, we're going to go ahead and divide by the 28 on both sides. And so we get 1 over 28 equals, this cancels, it's equal to x. And the last example, so here we have the natural log. So the natural log is going to follow the same rules as your logarithms when you're condensing or expanding. So here we have the natural log of negative 3x minus 1 minus the natural log of 7. So when we see minus, so we're going to write the natural log once. When we see a minus, we're going to need a division. On the top is going to go the negative 3x minus 1. And since we're subtracting ln of 7, that means the 7 is going to go on the denominator. And this is equal to 2. Okay, then we're going to go ahead and write this. Now, we don't have log on both sides like we did on the previous problems, okay? So we're going to have to write this in exponential form. So we take this base. Remember, the natural log, your base is e, so it's going to be e to the second power equals this. So e squared equals negative 3x minus 1 over 7. So let me see. E squared as a decimal is going to give me 7. I'm going to rewrite it here. 7.389 equals negative 3x minus 1 divided by 7. So since we're solving for x, I'm going to go ahead and get rid of this 7 in the denominator first by multiplying by 7 on both sides. And so on this side, we get 51.723 equals, the 7's canceled out, so it's equal to negative 3x minus 1. Then we go ahead and add the 1 on both sides, and this is going to give us 52.723 equals negative 3x. And then we go ahead and divide by negative 3 to solve for x. Let me go ahead and punch that in my calculator real quick, and that gives me 17.574 equals x, and that's it. Oh, there you go. Thank you guys. We'll see you next time. Bye.